All right, today we're diving into something really cool in the world of AI. It's a brand new technique called introspection of thought, or INoT for short. And it's all about teaching an AI how to think, debate, and even correct itself all on its own.
So, just think about this for a second. What if, instead of us having to constantly poke and prod an AI to get the right answer, it could just have an internal debate, challenge its own ideas and reason its way to the best possible solution, all by itself? That's the revolutionary idea we're going to unpack today. But to really get why this new method is such a game changer, we first have to look at how things have been done up until now. For a long time, getting an AI to think logically has been a pretty expensive and kind of clunky back-and-forth process. Yeah, the standard way of doing things is called external dialogue. You can picture it like a conversation that just never seems to end. You give the AI a task, it gives you an answer, you find a flaw, you tell it how to fix it, it tries again, and you just keep repeating that loop until you hopefully get what you're looking for. Now, this whole external dialogue thing comes in a couple of flavors. You've got chain of thought, which is kind of like asking a single AI to show its work out loud. And then there's the more complex iteration of thought, where you literally have multiple AIs debating each other round after round. And here's the massive catch. While these methods can get you there eventually, they have one huge, glaring problem. Every single one of those conversational turns, every back and forth, costs a ton of computing power. We measure that cost in tokens, and believe me, they add up ridiculously fast. So, this brings us to the big breakthrough. What if you could get rid of that entire external conversation? What if you could teach an AI to have that whole debate with all the arguments and corrections entirely inside its own digital head? And that's exactly what introspection of thought, or INoT, does. It just completely flips the script. The whole shebang, the debate, the critique, the self-correction, it all happens internally, in one single shot. It's less like a conversation and way more like an internal monologue. The AI is literally thinking to itself.
This quote from the research paper just nails it. They say that self-denial and reflection occur within LLM instead of outside LLM. That's the fundamental shift right there. It's moving the entire thinking process from the outside world to the inside of the model itself. So, how in the world does this work? Well, it's got a kind of secret sauce made of 3 key ingredients. First, it uses a really strict XML format for instructions, so there's absolutely no confusion. Second, it uses a cool hybrid language called prompt code, which blends programming logic with plain English. And finally, and this is the clever part, it creates 2 virtual agents inside the AI to actually have the debate. And this internal debate follows a super clear 4-step cycle. First, the 2 agents lay out their arguments. Then, they critique each other's reasoning. After that, they each come up with a rebuttal. And finally, they both adjust their thinking, and they keep going until they land on one unified answer. And the best part? All of this happens in one single, hyper-efficient process. Okay, so theory is one thing, but how does this new internal method actually stack up against the old, expensive way? Let's get to the main event and look at the hard data. Time for the showdown. Let's start with the most staggering number. On average, INoT uses 58.3% fewer tokens than the next best method. Let me say that again. It is more than twice as cheap to run. That is a gigantic leap in efficiency, right off the bat. Now, usually when something's cheaper, you expect it to perform worse, right? Well, that's what makes this so wild. Take a look. The old external dialogue methods can cost up to almost 85,000 tokens. INoT, it costs around 26,000. And for that fraction of the cost, it actually delivers the highest performance of all of them. It's better and cheaper. Let's break it down by task. When it comes to generating code, which is a really tough job for an AI, INoT scores an amazing 95.9. That blows past the best of the old methods, which maxed out around 90.6. Okay, what about something like complex mathematical reasoning? It's the same story. On a super challenging math benchmark, INoT once again pulls ahead, outperforming all the established techniques. And for tricky question answering that requires putting multiple clues together, you guessed it, INoT demonstrates a clear advantage here too. It's not just more efficient, it is consistently more accurate across all these different kinds of challenges. So you might be thinking, okay, This is amazing for text and code, but the power of this internal reflection doesn't stop there. It turns out it's also incredibly good when you start throwing images into the mix. Yeah, the INoT framework is incredibly flexible. You can basically plug in a module that understands images, and it can apply the exact same internal debate logic to figure out what's happening in a picture. And the results? They're just as impressive. We're talking about an average accuracy boost of 6% on really tough image-based Q&A tasks, so it can reason about what it sees just as well as it can reason about words. So, when you put all of this together, what does it really mean for the future of AI? Well, it's pointing to a really fundamental change in how we design and build intelligent systems. At the end of the day, what we're really seeing is a major paradigm shift. We are moving away from that slow, costly, conversational model of AI reasoning and towards something way more elegant, efficient, and self-contained. We're going from external dialogue to internal reflection. And this isn't just an academic exercise. This really matters, and for 3 huge reasons. 1, it just flat out performs better. 2, it does it for a tiny fraction of the cost. And 3, that powerful combination is what's going to pave the way for AI agents that are smarter, more efficient, and truly autonomous. So we've seen how teaching an AI to argue with itself makes it smarter and way more efficient. And that leaves us with one last really big thought to chew on. If an AI can now truly learn to think to itself, what on earth is the next frontier?